Hello, everybody, and welcome to this KNIME webinar. Today is the Meet the Experts Time Series Analysis event. So we'll get started here in just a minute or so. We've still got a few people trickling in, I see. But I'll start by kind of summarizing what the plan is for today, and then we'll kind of go around and introduce ourselves. So this is going to be kind of a panel discussion, Q&A. So I encourage everybody to ask their questions if you have some. It'll really help us have a more engaging experience today. To do that, you'll see at the bottom of the Zoom screen, you've got a Q&A button, kind of where the chat button usually is. It's two little text bubbles. If you open that up, you can post questions into the Q&A chat. You can also upvote each other's questions if there's one that is particularly interesting to you. That'll help us prioritize the interesting topics to talk about. And that's kind of how we're gonna run today's session, is through that Q&A tool. Don't worry about getting those in immediately. We've come preloaded with a few questions for each other to kind of break the ice a little bit. But yeah, so make sure you check out the Q&A tool. Ask us any questions you can think of about time series analysis, about the book, about writing, or just about KNIME in general. And we'll do our best to answer those for you. With that said, I'm Corey. I'm a data scientist with KNIME. I currently work in our Austin, Texas office, and as you might expect, I mostly work on time series analysis applications. You want to introduce yourself next, Maarit?
Sure. Yeah. So I'm Maarit, also a data scientist at KNIME, working mostly on education. So giving courses, creating self-paced courses, making videos, and this time series was a bigger project last and this year. And yes, I'm normally in the Constance office, so in Germany, and today I traveled to Zurich with this book to give this webinar. And yeah, thanks everybody for joining, and I'll give it over to Daniele to introduce yourself.
Thanks, Maarit. Hello, everybody. Welcome. So I am Daniele Tonini, and I am an educator and also a consultant. So in my life, I teach in university advanced analytics, machine learning, and of course, time series analysis. And regarding my job as a consultant in the past 20 years, I supported companies and organizations in many advanced analytic project, of course, involving also time series analysis. So that's why I'm here.
Yeah, we're very grateful to have you with us for all the time series work we've done over the last few years.
Yes.
So I'm just going to open up with one of the questions right away now. This one's for Maarit. Which strategies for missing value handling do you like to talk about? Which ones do we talk about in the book? I think that was one of your chapters.
Yes, that's one of the first chapters where we talk about pre-processing data for time series analysis in general. And one of these things that you need to do is to deal with the missing values. And I highlight there two things. So the first thing is that what kind of missing values you have. Sometimes they are completely random. And sometimes if you know your data, you know why they are there. So for example, a shop is closed, there is no sales, and there is a missing value in the data, or something was broken in a sensor, for example, and that produces a missing value in your IoT data. This is the first thing, to know why they are there and do this data exploration. And the second thing, also specific to time series analysis, is the techniques that you can use. So for example, in one technique often used is a seasonal lag. If you have a seasonality in your data, then the best approximation in a very regular data is to use a seasonal lag. So with daily seasonality in hourly data, the lag is 24, for example. And these techniques for regular data, and then one more thing that I mentioned there is for irregular data. So what do you do then? And some techniques to highlight there are, for example, in-sample forecasting or doing moving average, where you really don't have much information before and what the value could be, but you can then use the forecasting also in the pre-processing phase.
I like the example about the seasonal lag in particular, because a lot of the time when I think about missing value imputation with the time series, I'll, especially since I work with a lot of high frequency time series, I'll think about using like a linear imputation or even the previous value if I'm feeling particularly fast and dirty. But if I think of like a bar or something, and I've got a missing value for my alcohol sales on a Friday night, I probably don't want to use Thursday night's value for that because it's going to be completely different. So yeah, often last Friday is probably the best way to go. Another thing we talk about a lot with missing values in time series is that they don't always show up in your data set, right? Sometimes we're just missing rows entirely, so we don't actually have a missing value. So sometimes you might not even know that there's data missing. And I think we talk a little bit about our timestamp alignment component in the book as a way to detect those missing timestamps, to inject the missing values so that we can use these methods to impute them.
Yes.
Yeah, one thing that is really interesting about time series is that when you have to pre-process the data, you have really to do something a bit different compared to the usual cross-sectional data. So all the techniques that you use to deal with missing data, with outliers, it has its own kind of word. You have to deal with the temporal dynamics, seasonality, taking into account also the trend. So yes, it's an interesting part because it's quite a different job compared to what you do with the typical cross-sectional data. So yeah, that's one of the parts that is important to acquire and to master before working with time series data.
Certainly takes some getting used to.
You were, Corey, mentioning a time series component. Maybe there is somebody in the audience who is not so familiar with the concept of components, and would you like to give a bit of summary?
Sure. Yeah. So a lot of our focus on functionality in our Codeless Time Series Analysis book is centered around a suite of these things that we call components. So what components are is a way to encapsulate portions of a KNIME workflow. So say you've got a bit of your workflow that you reuse a lot. Maybe it reads files and cleans the data. Maybe it imputes missing values. You can encapsulate that portion of your KNIME workflow into this thing called a component, and you can use it from there a lot like you would a node. So it can be a shareable kind of quick way to build a custom node. A lot of our examples, and I think this is a really powerful way to use components with KNIME, are built on top of Python scripts. So let's say you've got a Python script that you use all the time, and you want to expose this additional functionality to some of your colleagues that might not be Python developers. A really easy way to do that is to bake some Python script into a KNIME workflow. We use some configuration options to control this Python script with the flow variables that are available in KNIME. And then we wrap it up in a component and we can share it. And the end user kind of has this experience where they're interacting with a Python script through the GUI available, just like a KNIME node. So that's what these components are. Not all of them use Python. Some do, but it's just a really powerful way to expose that functionality.
I also included in the introduction to KNIME Analytics Platform in the book, which is one of the first chapters, these two specific things that are essential for the Codeless Time Series Analysis. So one is the understanding of what is a component, and the second is the Python installation. So if you are a KNIME user but not so familiar with the time series functionalities yet, this is the chapter where you find also these instructions for this.
Indeed. On the Python note, there's actually kind of a new release in KNIME that I will take this opportunity to mention. So in our summer release, there's a new Python scripting node available through the Python Scripting Labs extension that comes with a bundled pre-built Python environment. Lucky for us, that bundled environment includes the stats models package that we all like so much. And it makes it very easy to use these components with that extension. In fact, I just finished updating all of our components that we use in this context yesterday, so that they all use this new labs extension. So the user won't have to fiddle with their conda environments or Python installs anymore. It'll just come bundled straight with the KNIME install with that extension. So definitely check that out. If managing your conda environments has kept you away from any of these components, or building your own Python-based tools as well.
That's a great news.
You, Daniel, developed a new component for this book specifically.
Yeah, exactly. I'm not a great component developer because, you know, I focused my life on other things, but actually it is like very funny to do a component when you have time to do it, and especially when you have the need to develop a new component. For instance, for the book, chapter number 5 of the book, the chapter is focused on dealing with statistical properties of time series, like how to identify the trend, how to identify the seasonality, and how to decompose time series, so to extract the trend and seasonality. And in the book, in the chapter 5, I mentioned one of the most popular method of decomposition, that is the classical decomposition. And actually, to do the classical decomposition in KNIME could be quite tricky, because we have to do a lot of steps, a lot of nodes to do it properly. So that's why I thought, all right, let's create a component to do it quite in a very quick way. I can show you if you want. I have here. Yes. So here from the KNIME Hub, if you want a component here, you just search for, I don't know, your thing that you want. So in this case, the composition. Okay, and you have components. And here you go. This is the component that I made for the book. This is quite straightforward. So you take this component, you drag and drop the component in your workflow, and finally it will look like this one. So here I have a time series. For instance, this one is the import Australian electricity production, one of the examples used in the book. Here you have quarterly data from 1970 up to 2011, I think, no, 2010. And yeah, this is very simple to apply the composition with this component. This is not the only option, of course, that you have, but this is one of the options. Here you select your time series, you select the length of the seasonal cycle, could be 4 for quarterly data, could be 12 for monthly data, and so on. You select the method for the composition, could be additive or multiplicative seasonality. And then you select also the method that you want to use for the estimation of the trend, the classical center moving average, that is actually the classical decomposition, or something that is a bit different, that is a polynomial curve. With the polynomial curve, you select also the degree of the fitting. Finally, you execute the component and you have the full decomposition here. So you have the moving average with the trend in red of the trend. You have all the components, so the trend and time series, the seasonal factors, the deseasonalized series, the fit series with the measure of error, in this case the mean absolute percentage error. So it's a nice component. And finally here in the output you have also all the series, so the estimated trend, the trend series, the deseasonalized series, and so on. So it's a quite interesting way to work with the component when, as Corey said, you want to encapsulate something that you do, that's something that you frequently do and you want to share with your colleagues. So it's a good way to do it. Yeah, that's a cool thing.
Yeah, absolutely. And even if you're not sharing components like that, decomposing a signal manually can be a lengthy process. It's not necessarily one line of code or one node in KNIME, depending on where you work. So it's always nice to be able to, snapshot that functionality and reuse it, even if it's just for yourself. That's a really cool component that I actually haven't had a chance to use too much yet. So I'm gonna have to go check it out some more. We do have a few questions popping up in the Q&A tool. So let's snag one of those while we have the chance. And for anybody who's joined more recently, there is a Q&A tool at the bottom of your Zoom window. Please use that. We want to answer as many of your questions as we can, keep this Q&A panel discussion as lively as possible. So go ahead, go down there, post your question, and if you see somebody else's question that you're interested in, give it an upvote. Okay, so the question here is, it's more of a request, really, asking for an example using cross-validation to improve accuracy. So that's a great request. We can certainly look into building an example that shows off how cross-validation works with a time series application. But maybe what we can do for today is talk to people a little bit about how cross-validation works with forecasting models, because that's not always an obvious answer. Rather, if you'd like to take that one, or I can talk about it a little bit. So we don't currently have a cross-validation for time series example, which is certainly why it's being requested, or component for that matter. But the way cross-validation typically works on a time series is, like, say you have, let's say, 4 weeks of data or something. Typically with cross-validation, you just kind of grab some random partitions, try like rotating around which portions of your data are used for training and which portions are used for testing, and kind of average those accuracy metrics that you get out of building a classification model in that way. But with time series, of course, we want to make sure that whenever we have a train test split, we're forecasting the future and not the past, because there's a bit of information leakage if we break that rule. So how do we handle cross-validation with forecasting? Typically, what we'll do is, say we take week 1, we train a model on just week 1's data, and we forecast week 2, see how it does. Then maybe we take weeks 1 and 2 and train a model and forecast week 3 and see how it does. And we kind of shift the portion of our time series that we're trying to forecast down the line in that way. And then we can kind of look at an average, see how the forecasting model works in different periods of our time series, all while maintaining the rule that we always train on the past and test on the future. So that's kind of how that lays out. And yeah, that would be a great thing for us to work on building an example for. We'll look into that. So thank you.
I think if you have the slide where is the link to the book on Amazon, because people are asking in the Q&A where they can find the book. Maybe we can keep that slide.
And we'll leave this one open while we're talking here, unless we need to share KNIME. So this is, of course, the cover for our Codeless Time Series Analysis with KNIME book. Very grateful to have published that with Packt. You can find it on Amazon, that link down here. If you search Codeless Time Series Analysis, you're probably going to find the book on Google or on Amazon faster than you could type that link, so I might recommend doing that. As you might expect, there aren't a ton of books with the similar titles. But yeah, you can check that out there. You can find some reviews on Amazon already. Very happy to answer any questions about it as well. Okay.
I think maybe if you can follow up on the cross-validation, because there is one question that it disturbs the sequence, but I think that's something that you explained already, but so maybe to highlight
I can add an extra comment on that, I think.
Yeah.
So as some bigger KNIME fans might know, we do have cross-validation nodes available in KNIME AP, but you won't want to use them for time series analysis, because they do the partitioning of the data set randomly, right? And we can't use a random cross-validation pattern to do this for time series. So we'll have to kind of build a separate way to do this, because we need to make sure that we kind of chunk it out in sequence and then shift down the line as we generate our forecasts. So it is different than regular cross-validation, which is kind of randomly spread out. So be careful not to use the regular cross-validation nodes or just a regular cross-validation function somewhere, when you're doing forecasting, you'll want to make sure that it is specifically set up to use the past for training and the future for testing. And one awkward thing about using cross-validation for time series that you might think of as you get into working on it is that you don't always have the same sized data set for training. You could.
It's a shifting data set.
Yeah, so it could be done that way, but just something to keep in mind, that's possibly normal. Okay. Let's see.
There's this one question about short life cycle products. I don't know, Daniel, if you see this question, but if you have some real life stories.
Well, first of all, when you have, this is one of the most popular question probably. How long should the time series be to apply a specific model, like an ARIMA model or another kind of model? It's one of the popular questions. Consider that it's not only the length of the time series that gives you information, but it's also the type of variability that you have in the data. So the amount of variability that you have in the data. So if you have a very constant time series, very flat in the dynamic and very flat in the behavior, so you don't need a lot of data points to predict for the future. If you have a very unpredictable kind of dynamics, a lot of changing trend, a lot of changing seasonality, in that case, you need probably more data points. So it's difficult to say how many data points you need. So in your question, if you have a short life cycle product, you want to predict for the future this kind of product with few observations, well, actually, you can also evaluate to apply an ARIMA model. It depends on really the type of time series that you have. If ARIMA, it's not okay. So typically when you have seasonality, I will suggest to use 3 or 4 at least complete seasons to estimate properly the seasonality with an ARIMA. If you have less than 3 or 4 seasons, probably I will recommend to use something like an exponential smoothing kind of model or an ETS model, that is new version of the exponential smoothing. Or if you want, you can try also using a decomposition. So you use a decomposition and then you apply the decomposition. So you take the seasonal factors and the trend estimated with decomposition, and you project for the future the seasonal factor and the trend to obtain a forecast for that short life cycle product. But yeah, consider that try to visualize your time series. Also, if it's short, try to understand better the characteristic of the time series, and then you can try multiple approaches.
Do you, Daniele, have some use? So is this retail sales, or where does this happen normally? That the life cycle is so short? Is it?
In my experience, well, yeah, it happens when typically you have a new product, right? Okay. So you have a new product that you probably put it in the market, I don't know, 1 year, 1 year ago. In that case, yes, it's quite typical. It's a sort of a cold start of your model, right? So yes, I know that sometimes you need many data points to obtain quite a good model with good accuracy. But of course, if you don't have data points, you should come to something, and you should try to do something. In that case, I would recommend to use decomposition or exponential smoothing rather than ARIMA.
Okay. There was also a good example in the chat. So mobile phones and cosmetics, true. Yeah, they don't.
Yes, exactly.
Yeah. Thank you for the question.
Yeah, I've got a related kind of question that I've gotten in the past, actually. It's kind of an opposite question, I suppose. It comes up a lot where people are asking, how much data do I need to build an ARIMA model? And I've certainly stolen your rule of thumb for 3 to 4 times the seasonality length in the past. One of the awesome things about the ARIMA model compared to a lot of other options like deep neural networks or something is that they really don't need that much data. In fact, you don't want too much data, which is kind of the opposite end of the spectrum with the ARIMA models here, is that you can be using too much data for your ARIMA model. In my experience, they don't handle very long time series very well. So if you have hourly data and it's going back 2 years, you probably don't need to use the whole time series to train an ARIMA model. You won't pick up on as much of the current features of the time series. That's one problem, of course, that'll probably damage your forecast value. But beyond that, it's going to take forever to train, right? So it is important not to use too much data when we're talking about these ARIMA models as well.
That's a good advice.
True. Shall we, Daniele, share this one question about anomaly detection? I think we both wrote about it a bit in the book, so maybe you can start and I tell about the use case. Yeah.
Sure. That's an interesting question about anomaly detection, because time series analysis and anomaly detection, they are related in two different ways. I think that the first way is if the goal of the analysis of your analysis is to do forecasting using time series, it is critical to detect and treat anomalies to get a better performing model. Okay, so that is when you have the goal to forecast with your time series. Sometimes recognizing these anomalies, it's not easy, because anomalies in a time series, they can be very of different types. Often they are just like additive outliers, just spikes. Sometimes you have level shift, sometimes you have transient. So it's difficult to identify anomalies in a time series. And it's even more difficult to treat the anomalies, because the main question is, do I have to clean the time series and removing the anomalies before doing the forecasting model, or can I model the anomalies right inside the forecasting algorithm, for instance, using intervention variables? So they are quite an interesting thing to think about. In general, there is no one-fits-all approach. You have to figure out which is better for you. So if to include anomalies in your model and try to model them, or if to clean your time series from anomalies. And if you think about COVID, right? So the last 3 years, a lot of my clients that have sales that are reduced in the COVID period, we have a lot of forecasting model in production. So finally, we decided to treat the time series like removing the COVID pandemic and trying to interpolate the time series like COVID never happened before. This is before doing the models. So this is the approach that we follow, but of course, there are many approaches. So this is the first way, the first kind of relationship between anomalies and time series, detecting the anomalies inside time series before doing the forecasting model. The second type of interaction is kind of opposite. So you can identify anomalies through the use of time series. So this is kind of different approach. In this case, your goal is anomaly detection. So imagine you want to detect anomalies. So you want to detect a fraud, you want to detect a possible failure in your equipment, and some kind like an attack in your IT system, so cybersecurity. So there are many anomalies that you want to find, to detect, and time series is one of the possible methods to detect these anomalies. So you can have supervised method, unsupervised methods, clustering, and so on. But time series, they are quite effective in detecting anomalies, especially for predictive maintenance purpose. And actually, I mentioned this thing in the first chapter of the book, but we have chapter 11 of the book that is dedicated to a specific use case using the time series analysis to detect anomalies. I don't know if Maarit, would you like to add some more details?
Yes, one thing maybe to scare people a bit less, because the anomaly detection is really it's important, and there are so many things that you can do around them. But in this chapter 11, I introduce one very simple but powerful technique. So it's the control chart, and basically the logic behind that is there is no machine learning. There is really a simple logic, which means that you calculate the long-term statistics, so the average and standard deviation, and then you compare the incoming signals to this and determine if they are normal or not. And this, if I don't know, in this use case, what I have in the book, we have some sensors monitoring a mechanical piece in some industry, and these incoming signals, I don't know the frequency, what it is, but they are always compared to this long-term normal. And if they exceed it, they raise an alarm. And together with what we can build around it, an automatic alarm system or any kind of handling of the alarms, it can be very useful to start with.
Yeah, there's so many cool ways to work on anomaly detection and predictive maintenance on time series. I honestly think it's one of my favorite topics in the already subfield of time series analysis under data science, is this predictive maintenance and anomaly detection stuff. We talk about how we can use the Fourier transform to extract characteristics from time series and look at how those characteristics change, to judge whether or not there's something happening to the time series that could be considered anomalous as well. So there's just so many different ways to do it. We talk about a few different ones in the book, so definitely check that out if it's something you're interested in. There's a couple kind of questions here that I just kind of want to touch on really quickly while I've got them. There's one saying, how do you develop deep neural network models in KNIME? So we actually touch on this in the book as well. I can't remember the chapter numbers off the top of my head, but we have a chapter on how to use the Keras extension in KNIME to develop forecasting models using standard feed-forward networks. So that's kind of the introduction to deep learning, the Keras extension, and kind of how to start using that on time series. And a second chapter on deep learning, where we talk about how to use LSTMs as a way to improve the quality of your deep learning models for forecasting purposes. So there's two chapters in the book talking about how these neural network models can be used. But if you just want to play around with it, just install the Keras extension for KNIME, and you'll get some new nodes, and you can build custom architectures and play around with a lot of options for how you train that model and everything.
Thank you, Corey. Just checked here, chapters 9 and 10. Yeah.
Thank you. I knew it was somewhere in the later half of the book, but I just have totally blanked on the chapter numbers. Okay, and there's another question here. Can external variables be included in KNIME's ARIMA model? As of today, not yet. There is good news there, though. The package and the functionality that we've used to develop these ARIMA models do support these exogenous variables. So that's something that we want to add, hopefully in the near future. If you're a Python savvy guy yourself, you can certainly open up one of these ARIMA components and make the edit without too much trouble, and incorporate those. So it's very possible. It'll give you a chance to play with components a bit. But yeah, that's absolutely something I want to add. The functionality is available, just needs to be developed and turned into a component.
So do you know, Corey, if it's a ARIMA X model or it's ARIMA with ARIMA errors? You don't know which one is? Because there are two different ways to model external variables in the ARIMA
so
models.
The way that I'd be looking to add it would be with the ARIMA X model. Currently, the functionality that we use is literally the stream X function from stats models.
Stats model,
these components. So it's like the function's there, everything's set to go. That's the one that we can add easily. Do you want to talk a little bit about the other options?
No, yeah, there are two options. ARIMA X is when you directly include the regressors in the equation, right? The other option is the regression with ARIMA errors. So the advantage with the regression of ARIMA errors is that you interpret the coefficient like a normal regression, and you model the time series part in the errors. So it's more straightforward when you do the interpretation of the coefficient if you use the regression with ARIMA errors. That is basically the only advantage.
Yeah, I mean, that's a big advantage, though. I know we can't really neglect all of the new laws and regulations that are passing that require more and more explainability in our models. So definitely something to keep in mind. Have to look into which one we ultimately implement, if not both. But the Streama X is certainly an easy addition to the existing Streama components.
There is this one more KNIME related question about the influx DB. I'm not familiar with the database, but I can just say that there is the general DB connector node, which you can use for basically any database where you just have the JDBC driver registered separately. So if that's what your database provides, then it's definitely possible.
About Prophet, I don't know if you guys use Prophet in some applications. I use it recently. So for a project, I use it Prophet to predict weekly sales. So when you have a weekly seasonality, it could be quite not so straightforward to deal with the weekly seasonality because the frequency is not constant. It's not 52 every year, so it's not an integer. And with the ARIMA models, yes, you can approximate to 52, but sometimes you have some shift in the seasonal component, so it's not so straightforward as I said before. So with Prophet, you can deal with seasonality in a more flexible way. So in general, Prophet, it's more flexible than ARIMA probably. But finally, it turns out that in my case, Prophet with external predictors, because in my case I use ARIMA with ARIMA errors, so like ARIMA X. The ARIMA X was the performance was better than the Prophet model, also by far actually. And so my only experience with Prophet, it seems like in theory a very good algorithm, very flexible, but as far from the performance, in my case, ARIMA was better.
Yeah, I think an important thing to bring up when we talk about Prophet is that, strictly speaking, it's not a full-bodied AutoML tool. I know people have thought of it that way in the past a lot, especially after, maybe some of you remember, all the news about Prophet and Zillow. I think that was last year. So Prophet's a powerful tool, lots of functionality, but you'll still want to know how your time series models are working and what your time series is doing behind the scenes as well. So you can make sure you select all the right parameters.
Yes.
Let's see. So there's another question here. Can KNIME be used as a payment forecast tool for payment schedules? What types of models could be suitable for a task like this? Let's see. Does that resonate with you at all in any of your
payment schedules? So what do you mean, Borislav? What kind of time series you have? So first of all, it's a kind of regular time series. So if you have to plot your payment schedules, what will you see? So it's it depends on the type of time series.
Right. There's So typically when we're talking about the forecasting models that we do in this book, and today we talk about forecasting, anything that's regularly spaced, really, depending on the scale of the time series and the types of seasonalities present inside of it, we might use different kinds of models. But for the most part, we address any kind of regular time series with this book. Of course, we don't touch on every single algorithm out there. We don't have a chapter on profit in this book, maybe in a volume 2. Yeah, so for the most part, if your forecasting problems are about forecasting values of regularly spaced time series, meaning your timestamps are equally separated, so you've got like daily, hourly, weekly, monthly, whatever data, then the approaches that we talk about in this book are going to be great. Typically, when I'm choosing between things like the ARIMA and SARIMA models versus something like an LSTM, what I'm looking at is the scale of my time series, right? Because I don't want to use an LSTM on something where I've only got 200 data points, and I don't want to use my ARIMA model on a 20,000 row long time series either. So lots of things to consider there, but yeah, maybe we can talk a little bit on that note about how you like to handle irregularly spaced time series, Daniele. Any advice for people on that topic?
Well, the main advice in this case is to make it regular. So for me, yeah, for me, just using irregular time series, of course, if you're using quite a classical approach, you make it regular, you group the observation in order to make it regular, and then you use a classical approach. So that's my, probably the best way to deal with irregular time series.
Yep.
We have many questions.
There is this one question about the KPIs based on quantities and claims. I don't know what I start thinking is here that you have these other variables that you use for forecasting. So is this more a use case for machine learning based forecasting?
No, probably.
It sounds like
this
could play out a couple different ways. If your KPIs are, directly derived from these quantities and claims time series, then you could certainly try to forecast your claims, and from there, generate your KPIs from this forecasted data. If we're talking about, forecasting one time series separately or together with these other ones, we don't currently have a support component for multivariate forecasting, although that's also, kind of on our wish list. I would call the wish list SARIMA X models and multivariate stuff probably in that order. I want to say there's a couple other things that are on my to-do list, but those are the ones that come to mind at the moment. So there's just kind of a couple ways that you could look at that. If your forecast KPIs or the KPIs you want to forecast are directly based on these other series, then sure, you can forecast those. There
is one big warning, Corey. So every time you use an external regressor, so like in this case, for instance, you want to predict the KPI, a matrix of revenues, performance, whatever you want, using quantities or claims. So as you said, yes, you can absolutely use that quantities or claims, integrate them in the model and use them to forecast your KPIs. But remember that for the future, if there is a connection that it's not lagged between the KPIs and your claim or your quantities, to predict your KPIs for the future, you must have the number of claims and the quantities, right? So, and the forecast, in that case, it is probably based on another forecast. So it's kind of, you can increase the error in that case. So be careful when you use external regressors or exogenous variable in your time series model, because it is possible, and actually it is quite typical, that you have to forecast also the exogenous variable before having the prediction of your main target variable. And this is one of the main problems with the external variables, having them available in the future. So
right.
one thing is, okay, I have a promotion, right? And I have the effect of one promotion on my sales in the past that I can model. And of course, it is probable that in the future, I know when the same promotion is going to happen. In that case, no problem at all, because you use an intervention variable like a dummy or something like that. But when you base your prediction on external variables that are not known in the future, well, in that case, you introduce more variability in the model, and this actually could,
Right. Yeah, we need to be very careful when we nest our confidence intervals, as they can explode quite quickly. Very good point. So maybe not good to have a model based on another model, but be very careful. Good point. Okay. Let's see, what else do we have here?
Can KNIME be used to create forecasting model for manufacturing domain? I think chapter 11, right?
Yes, that's actually a chapter which starts from the accessing IoT data and how to handle it, how to determine the problem of anomaly, that it's really something that you see just by taking a look at the short window in the data, but it's something that gradually changes. And it introduces three approaches. So one is the control chart that I mentioned, and then there is the machine learning approach. And it concludes also the different actions, what to do when you detect these anomalies. So there we also touch a bit KNIME server for automating an alarm automatically when the workflow is scheduled automatically, so that it triggers another thing from that workflow.
All right, we've got a question in the chat that's getting quite a few upvotes now, so I definitely want to make sure we address this one. It's kind of open-ended a little bit. Any tips regarding having to mix R or Python with KNIME when there's a large quantity of time series to forecast? I assume that means not necessarily a large time series, but many separate time series that we're looking to forecast, and kind of just how we handle that. I assume a common example where that might come up is if you've got a bunch of different product lines in your store or something along those lines, and you want to forecast your sales for all of those separately. Yeah, so memory performance, etc. I don't have any tips on hand from the, how to build good Python code for that per se, but there's lots of ways that we can use KNIME and kind of blend in these scripting languages. R or Python is kind of really your choice to kind of facilitate this work. So let's say we've got a bunch of time series separately in a table. There are different loops in KNIME that we can use to loop over those time series and generate forecasts for them all. The downside to doing it that way might be that you're doing them one at a time, and maybe that's not what you want to do. But there's also a loop in KNIME called the parallel chunk loop. And this is one that we could kind of twist around a little bit to make all of these models train concurrently. Of course, training a bunch of different models at the same time is going to be a performance hit, and they'll probably go a little slower. But in general, I think that works a bit better. Most of the models that we talk about in this book are going to be things that are, not necessarily going to get pushed to your GPU. The deep learning models available in KNIME can be pushed to your GPU, and at that point, that's great. But a lot of these other ones are going to be kind of single-threaded algorithms. I'm not aware of a GPU algorithm for the ARIMAs, for example. I don't know if you've seen one, Daniela, but those are probably going to be single-threaded. And yeah, we can certainly train more than one of those at once without too much of a performance hit. So I would recommend looking into using that parallel chunk node to kind of split out all of these separate time series and generate your forecast, be that with, you know, on our script of your own, or with some of our Python-based components.
Yes, if I may add one thing, in the past, actually now I am using a lot the integration of R and KNIME. That is really a win-win kind of approach, in my opinion. So you can benefit of you know, the flow of the KNIME to organize the process. The data integration in KNIME is very cool of all the time series component. So you can benefit of everything that is described inside the book, but sometimes if you need a specific library or a specific way to deal with time series, especially if you want to use some R libraries that are quite good for time series, like the famous forecast library or the new Fable library. It is based on TS-able data frames that are quite effective if you want to stack multiple models and multiple time series. So I do recommend to check it out, the Fable package, if you want to train multiple time series models or hierarchical time series model inside a node in KNIME. With Fable, it is quite good.
Great tips.
Thank you. I can take the next one. I can summarize myself here because it's about the time granularity. So does it make sense to use smaller or bigger time intervals? And this is something that we touch in the pre-processing chapter number 3, I think. And there is a dedicated subsection for that. And I can say 2 keywords here. So they are the forecast horizon, and the other one is also the regularity of the data. So if you want to make daily forecasts, then data that you use for the modeling must be at least daily, of course. And often, for example, the hourly fluctuation that you have in daily sales is just not necessary to predict the dynamics in the days further ahead. And on the other hand, so for example, stock market data is often very irregular and you cannot aggregate it much to make more sense of it, and then you just don't do it. So please keep these 2 things in mind.
Yeah, I think that's one of my first tips when I talk to people about time series analysis. We'll talk a lot about the granularity of their data. And the question really should ultimately bake down to, what is the model output that you require, right? If what you need is a monthly forecast, then forecast monthly. If you don't need daily, there's just a lot of noise that you can eliminate. Sometimes people are generating forecast models that ultimately just turn into classification models as well. Like, for example, if you're trying to figure out if you're going to run out of supplies at the party next week, you don't strictly need to forecast the exact number of, cakes that you're going to need for the party. You might just be able to forecast with a classification model. So there's lots of ways that we can kind of boil down and kind of condense the question that we're trying to answer with models in general, just in general in data science. And that's true in time series as well. As Maarit says, definitely aggregate if you can. Yeah.
I'm posting the link in the chat to the Amazon page.
Thank you.
Actually not in the chat, but in the Q&A.
Okay, let's see. I'm kind of scrolling through here a little bit, looking at some of your questions. We are coming up on the last 5 minutes of the Q&A panel discussion webinar event thing. So if you've got any final questions for us, now's the time to put them in the chat. And we'll do our best to answer those ones that we can. I see one here about how to set up a GPU to train deep learning networks with KNIME. That's one that I can answer. I can take that one here. So the deep learning in KNIME is based on Keras. So it's kind of a Python integration that we distribute and support. So you'll download this extension. It'll add the Keras nodes to your node repository. You can drop them into your workflow just like anything else to build your architecture and train your model. If you go into the KNIME preferences, you'll be able to kind of configure in there what type of environment you want to use to run these Keras nodes. You can either use a standard CPU-based one, or you can use the Keras GPU-based one, and that'll be found under your Python deep learning, I believe. So you go into KNIME preferences, and then Python for deep learning, and that's where that setting will be. Do keep in mind that because the Keras GPU is based on CUDA, you will need an NVIDIA graphics card to make that work. So I think most people are running NVIDIA graphics cards, so hopefully that's okay. But that's just the nature of the Keras GPU package at the moment.
Do you, Daniele, have some favorite question here to select? Which
I'm actually, I was replying to a couple of questions with the chat, but I can do it.
I've got a question for you, Maarit, while Daniela checks. And this one's actually just coming from me. So I'm curious which chapter that you wrote is your favorite, or perhaps which one was really hard for you to write. I know some of the chapters seemed like they just kind of wrote themselves, and some of them were a real struggle too.
Oh, yes.
A favorite, maybe?
Yeah. Now, I will combine this answer with one question from the chat. So what I really enjoyed also which was also a learning experience for me, was the last chapter about the stock price modeling. It combines many things, and one of the things that it combines is the integration with the H2O machine learning integration or machine learning platform. And I like it very much because it's so easy to use. So you need install the extension and you can start using it. It's very user-friendly in that sense. And why I selected this one is because there's the question about the automated lag selection. And in this chapter, the use case is very time sensitive. So we need fast predictions of the stock prices. And at the same time, the data is changing very quickly. So we need to retrain the model frequently. And there, one of these things that we do in the model training is feature selection. So we provide 10 lagged values to predict the next day's stock price, but we don't always use of them. And we just perform feature selection to decide, okay, which lagged values provide the best forecast. And this feature selection is actually quite heavy operation. So it takes a lot of time, and it makes the model computation slow. And that's where we benefit from the integration with the H2O, which makes it faster to train the model. So this is a summary of the chapter and also an answer to the question. There is an example of that lag selection, and it's in the last chapter.
Yes, that can be a difficult one.
I'm trying to reply to all the questions.
What was, Corey, your favorite chapter?
I think my favorite chapter was probably the chapter on the Fourier Transform. I think there was also a chat or a question here somewhere about the Fourier Transform and neural networks. I've never actually used the Fourier Transform and a neural network in the same pipeline before, but they are definitely both available in KNIME. And I really enjoyed writing the chapter on the Fourier Transform because in my studies, that was kind of my focus, was a lot on signal analytics. So I used the Fourier Transform a lot in the past, and it was nice to revisit that. I will say that it was also, out of all of the chapters that I've written, the one that one of our technical reviewers ripped apart the most. because she happens to have a strong background in signal analytics as well. So it was a stressful but also very fun chapter to write. So if you're interested in the Fourier transform, definitely check that one out. It certainly is available in KNIME. All right. Well, we've got just 1 minute left, so I think maybe we have time for one more. If you've got one that you found, Daniela, otherwise we can kind of wrap up and thank everybody for coming, and certainly reach out to us on LinkedIn or wherever at another KNIME event, and we'll be happy to answer more questions. All right.
Yes.
There will be a time series course happening in November, right?
It'll be, I believe it's in early December.
Yeah.
First week of December, I think we'll be hosting our time series course. It's an 8-ish hour course that we host over 4 or 5 days, kind of covering not everything that's available in this book, but some of the things that we see in this book we also talk about in that course. Namely, the ARIMA models are touched on, as well as a little bit on LSTMs. So if that's interesting to you, come join us in December. You can find that registration on KNIME.com/events. And yeah,
Yes.
one further thing I can plug, I guess, is that the KNIME Summit is coming up in Austin in just a few weeks now. It's November 14th, 15th, and 16th. There'll be a day of KNIME courses. There'll be a lot of customer talks on how people are solving their business problems with KNIME, as well as some workshops. We're going to be doing a small book signing event at the summit. So that'll be an opportunity to get some copies of the book there as well. So definitely come to that and we can chat, and you might even get a free copy.
Yes, I just want to quickly show you where you find these things. So here's the time series course and also the KNIME Summit. If you go to our homepage and then to the events from here, so you find the summit and you find, for example, this webinar here.
Here we are.
Yeah.
Mm-hmm. All right. Well, I think with that, we can wrap up. So grateful that we had good questions from everybody. Stay in touch.
Bye-bye.
Bye.
Thank you, everybody. Thanks for attending this webinar. Hope you see you in the future.